Welcome. Let's solve Leetcode 689, maximum sum of three non-overlapping subarrays. They give us an integer array nums and an integer k. Find three non-overlapping subarrays of length k with maximum sum and return them. Return the results as a list of indices representing the starting position of each interval, zero indexed. If there are multiple answers, return the lexicographically smallest one. Okay, so let's go over this first example here. First and only. So what they're saying is for this nums array, if we consider the array 1 and 2, 2 and 6, 7 and 5, that is the maximum sum possible out of every location with that satisfies this constraint where each subarray is of size 2. And so notice how 1 starts at index 0, 2 starts at index 3, and this 7 starts at index 5. So this is what they are expecting as the return result. Oh, my apologies. This is also an example. And similarly, 1 and 2 and 0 and 1, and here's 2 and 4, 2 to 3 and 3 to 4. And so this is basically the result they're expecting. Of course, there are other results that would yield the same answer, but remember they want the lexicographically smallest one. Okay, so let's go over I guess an approach we'll be using. The approach that I recommend is similar to a sliding window, but it'll just be a variation of it to accommodate what they're asking for, because they're asking for 3 non-overlapping max subarrays. Okay, so let's go over my approach. Okay, let's make this a little bit bigger. Okay, so let's go over this example they gave us. So what we could do is, it should be obvious that whatever we know, we have to start somewhere like this. This would have to be the first array, and maybe let's do this here. So something like this here, that'd be the first one. Second one would go somewhere here, and the third one would go somewhere afterwards. So what we're going to do is start with our initialization, something like this. And then we'll slide them down and record the best as we move along. Okay, so I think we can just code that immediately. So let's do that here. So what I'll do this, I'll call this maybe window sums, and I'll store each of them in here in an array. So this first window sum will have the numbers, so the sum for this first window. So we'll set the sum of n. Now n from where to where? So we want it to be, we're told that our subarray size can only be of size k. So we're going to go from that first, the 0th index to the kth index, -1. Okay, so hopefully that makes sense. Then that means this value would be 3, because I'm summing them. And this would be sum of, now where do we start from? Well, we can start at k, and we can go to 2 times k. And so remember, k is 2. Well, in this case, we'll set k equal to, this is just like the example they gave us. So in this case, we're starting at 2, 0, 1, 2, and we're going to 4, but remember the way slices work in Python, we don't include that index. So we're going from 2 to 3. And lastly, we're at sum of n to 2 times k. And where do we end? Well, 3 times k. Okay, so this is what we have. So in essence, we would have something like this. This would be what, 3, 3, 13. Because so the first 2, 3, 3, and 13. That's what this would look like. Now, remember, we want to store our max sums as we move along. So let's make a little comment here. These will be our window sums. Yeah, a current window sum. And our next variable will be our maximum sums so far. Maximum sums so far. Okay, so I'll call this m sum equals. Now, the maximum sum would be our window sum, but we just want to, this maximum sum is just going to hold the maximum sum for the first window. So maximum sum for sum so far for window 1, window 1 and window 2, and window 1, 2, and 3. So this is going to be a little bit interesting. So this maximum sum will hold the maximum for window 1. The second value will hold the maximum for window 1 and 2. And the third value would be the maximum sum for windows 1, 2, and 3. So currently, the maximum window sum is just this value. So window sum, we can just do, well, if we wanted to, we could just do window sum of 0. Because that's this, just this first value. But now, we want to sum the window sum from 0 to 2. We want to sum both of these, because remember, this is going to hold the maximum for window 1 and 2, and so currently it's both of them. And lastly, we'll sum all of them. So it'll just be, we can just do all of them. It's fine. Max. So yes, window sum. Okay. So let's see what this would look like. This would look like 3, 6, and what is this? 13 plus 3 plus 6 plus 19. Okay. And does that make sense? Let's look at it. So 1 plus 2 is 3, so that's here. And here's 3 plus 3, that's 6. And then 13 plus 6 is 19. So that's what we have. This is currently so far. Okay, great. And lastly, we want to store the indices of where the maximum sums originate. So I'll call this I sum, and this will equal 0. Just call it 0. This is, oh yeah, so then this is going to store where each of them starts. So then this one's going to store where 0 and k, that's where the first and the second window start from. And this is going to be where all 3 windows start from. So 0, k, and 2k. Sorry, 2 times k. So remember, the maximum sum is storing where is accounting for all of the windows. So when we return our result, we're more concerned with the last one, because the last one has all of the starting indices. So we can kind of maybe just do that now. So we can just say return the index sum of the last one, because this is going to be the index that stores all the starting indices. This first one is only concerned with the first window's starting index. The second value is storing where the first window and the second window are starting. And then the third window stores where all of the windows are starting. And then it'll make sense as we run through it, how it'll make it easy for us to solve it. Okay, So now let's move our windows. So now we need to practice moving our windows through the entire numbers array. So for I in range, start now. Remember, we're already here, so we need to start at the sorry. We're here. We can only go so far. So what we're going to do is we're going to say length of nums. Now, how many windows are there? There's 3 windows, right? And each of them is of length 2. So we can only move up to the length of n minus 3 times k. I hope that makes sense. So remember, we need at least 3 times k for the windows, so we can only move this far. So in essence, this would be, so length of k is, sorry, length of n is, what is it, 2, 4, 6, 8? 8, and this was 6. So we can only move 2 spaces. And that makes sense, right? Because we only have 2 left that are unoccupied. But this is, all of the windows combined need 6 spaces. So we can only move forward 2 for our exploration. So I hope that makes sense. Okay, let's move on. So let's try moving our first window. So window sum of 0. That's this guy, this first window. Let's try moving it over. So we're going to move it here. So if we move it there, what happens? We need to subtract this first element. And then we need to add this element. So let's do that. So what we're going to do is we're going to say, okay, plus equals. So we're going to add this guy. So n of I plus k. So remember, k is 2. K is 2. And then right now, I is 0. Remember, this goes from 0 to 2. So currently I is 0. Let's just put that down there right now. I is 0. So 0 plus k, which is 2, is 2. So that's, what is this doing? This is adding the new guy, but we need to subtract the old value. So we'll say, okay, minus n of I. That's the old value. Okay, and we'll do this the same for all of them. So the window sum for index 1 would be, so we need to add the new guy. So the new guy is going to be, so it's 2k plus I. So yeah, so it's 2k plus I. So, or I plus 2 times k. Minus what? So I plus k. I plus k. So let's go over what I plus k is. So k was originally, is still 2. And we need to subtract this guy. So that's at, that is 2. At index 2. So we need to get rid of it. And then we need to add the new guy, the new element, which is at 2 times k plus 1. So k is 2, 2 times 2 is 4. So 0, 1, 2, 3, 4. So this is our new element that we're adding. Okay. And lastly, hopefully you see that this is also going to be similar. So the window sum for the next guy, so we need to move this window over. So we need to subtract this value, which is at 0, 1, 2, 3, 4, which is 2k. So 3 times k, so 6 plus I, so let me see. 0, 1, 2, 3, 4, 5, 6. Oh, this is the value we're adding. Then we need to subtract that guy. And the value that we're subtracting is I plus 2 times k. So 2 times k is 4, and then 4 plus I is 0. So we're subtracting 0, 1, 2, 3, 4. Remember, this is where we started from, and now we're here, so we need to remove it. So now this moves all our windows. So move all windows over by one index, which requires subtracting old value and adding new value. So for all of them, remember, so we were here, so we just subtracted, we subtract one, we subtract this one, but then we add this one. Then we move it over. Same thing here, this was over here before. So what we've done is we subtract this one, but we add this 6. So then we move it over. And then same thing here for this last window. We were here at 6 and 7. Now we subtract the 6 and add the 5. So that's what we've done here. That's what all of this has done. Okay? And now we need to check if our new windows have changed our maximums. So let's check that. So if Windows sum 0, that's our first window, is greater than what? So remember, we stored, where do we store maximums? We stored them here. So if the new window size, so if this window, the current window, Windows sum 0, is bigger than max sum of 0, then we update it. So then we update it. So then we say, okay, the max sum of 0 equals the Windows sum at 0. But if that's true, then we also need to update our index. So we can do this, or we need to say, okay, the index sum of 0 equals, now it equals I plus 1. So remember, we were at 0, and now we're at, we move it 1 over. Okay, so then I'm actually just going to combine this into one line. So it just becomes I sum of 0 and I plus 1. Okay, moving on. Now we need to do the same thing for our second window. We need to compare if that's bigger than the previous one. So we'll say, okay, if the maximum sum of the first window plus the Windows sum of 1 is greater than the maximum sum of 1. So now let's go over what this means here. So the maximum sum is the biggest size of window 1. So biggest size of window 1. Now what is this here? The window sum of 1. So this is the current window. So the current window is where we're at currently. So remember, this is good here because it ensures that they don't collide. So the current window and the maximum, there's no way that they can collide, they can't overlap. Because the maximum sum window for the first window hasn't gone to this space yet. We know that. So I just want to make that point clear. So if it is, we can update it. So then we just say, okay, the maximum sum of window 1 equals, and we'll just say it equals this here. And then we say that we need to update the index sum. Now the index sum of 1 equals wherever the index sum of 1 equals wherever the first window is located. So we say I sum of 0 plus the index of where the current window is located, the current second window is located, which is at I plus k plus 1. So remember, let's go over what this equals. So I plus k plus 1, I plus k plus 1. Let's go over what that equals. So we know k equals 2, and we know I equals 0. And then, well, this is 1. So this equals 3. Now, does that seem right? Let's check it out. So 0, 1, 2, 3. Yes, this is where the second window is located. Okay, carrying on. Then we need to check if the third window needs to be updated. So then we say, okay, if the max sum for the second window, well, let's think about this here. What does this really mean? This is the max sum of window 1. But max sum of window 1, remember that holds the maximum for window 1 and 2. So this stores the maximum sum for window 1 and 2. So that's okay. Then what else are we missing? We need to add the current window for window 3. So window 3 is going to be window sum of 2. Now, is that bigger than the maximum sum for window 2? If it is, we need to update it. So then we'll just maybe copy this. Maybe let's do this here. Okay. And then we also need to update the index though, if this is true. So then we say, okay, so the index sum for the third window is going to be where? So it's going to be the index sum of 1, because remember, what does this store? This stores the best location for the starting points for the first window and the second window. So that's why we put this here. But then we need to tell it, okay, but where's the third window starting? The third window starting at here, I plus 2 times k plus 1. And let's go over what that looks like. So we know I is 0 currently. We know k is 2, so 2 times 2 is 4, plus 1. So this gives us 5. And does that make sense? Well, let's go back up here. So 0, 1, 2, 3, 4, 5. So yes, that's our current window. We're at 7. We're at 7. So we're good to go. And we would just proceed on in this manner, and just let the windows do its work, or let this shifting take place, and then we could return our answer. Let's check it. Okay, looks good. Let's submit it. Okay, looks pretty good. So if you found this video helpful or educational in any manner, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.